Totally think it is.
I'll prove it to you using trig functions. So I just got finished attaching this string to the very top of the pole, and this I will put it all the way down here, and I'll mark it so I know how far we are, and this will be the hypotenuse. Okay, so now this is the line that I drew, and we will measure the base of triangle with this thing, and it is exactly 8 feet. So using a protractor and the string, we can put it right on the 8-foot line and measure the angle of elevation right there, and it comes out to 47 degrees. Okay, so now we're back inside. We can undo the swing set, and this is the ground, and this is the swing, and this is the triangle that we use to find the height of the swing set. This one there. And when we backed up with the string, we knew that this was 8 feet, and we knew that that angle, using our protractor, was 47 degrees. And then this is a trig function, tangent, because we can do the opposite over adjacent is tangent. So if we do tangent of 47 degrees times the 8 feet, we will get the x height of the swing set. So then this is just a matter of punching into your calculator. So if I just do tangent 47 times 8, we get that x equals about 8.6 feet as our final answer for the height of the pole. I will now validate my calculations by finding out the real height of the pole using a tape measure. So we measure it exactly 8 feet and 7 inches. So I'm shorter than this pole. Okay, looking at our data, we found it to be 8.57 feet. It was 8 feet 7 inches. When you change the inches to the fractions of a foot, you get that. And then when we measured it with the tape measure, we got 8.58. So overall, our data is extremely close to the real height, so we have a very small margin of error, but of course there is always margin of error, so especially for something like this. But yes, so here we go.
So me and Willow are having a rubber band fight, and she's been beating me this whole time. So I'm down to my last rubber band, and I really want to hit her in the eye. So we're going to use Trig to see where I need to aim. So the first thing I'm going to need to do is measure the height from the table to Willow's eye, my target. And it comes out as 23 inches. Next thing I'm going to need to do is measure the distance from me to Willow on the table. And that distance is just about 71 inches. So from my gun to Willow's eye, the distance of the table was 71 inches, and the distance from my gun, which was at the base of the table, to Willow's eye was 23 inches. So to find the angle I need to shoot my gun at to hit Willow's eye, I'm going to need to use inverse tangent. So what I'll do is I'll do tangent inverse of opposite over adjacent, so that's 23 over 71. And that equals about 17.9 or 18 degrees. So now I know that I need to shoot at an angle of about 18 degrees in order to hit Willow in the eye. So I'm going to measure 18 degrees from this. If we draw the line, it will be 18 degrees just below 20. So I'm going to load up my gun.
Ah! She got me!
Yes, I got her!
Okay, so a third application of trig would be the typical, like, finding the distance to an island if you're on a beach. Of course, we can't go to a beach and find an island right now, so we created a small scale example in which this is the beach in which me and Zainab are stranded on, and this lovely tropical island on the sink is where we want to find out how far of a distance it is to get there. So we'll have to do this using trig functions. Okay, so the first step in finding out the distance would be this is the length of the beach, so we're going to measure the angle about from each end of the beach. So the first one, we'll place our protractor at our point and use a ruler as sort of the dial of the protractor, and just using my eyes I can figure out about where it should be, and it's about 70 degrees. So then on the other side of the beach, we'll do the same thing. We'll measure about where it should be, and it's about 44 degrees to the island from here. And so then the last measurement we need is the length between the two angles that we took. So using the it's exactly 5 feet or 60 inches.
I'm going to fill in my numbers over here. We had 70 degrees here, and the length of the total countertop was 60 inches, and this length was 44 degrees. So now what we're going to do is we want to find the distance from here to there, but we don't want to assume that this right here is a right angle. So what we're going to do is we're going to find this length x by using law of sines, but first we need to find this angle, and we're going to do that by doing 180 minus 44 minus 70, which gets us 58 degrees. So we're going to use law of sines with this 58 degrees. So sine 58 degrees over 60, which is our length, equals sine of 70 degrees over x. So when we do the math on our calculator, we get that x equals 66.5 degrees, 66.5 in length, inches. Now we're going to find the area of the total triangle by using 1/2 AB sine C, and when we plug that in, we get 1,385.8. So we know that that's the area of the total triangle, and so we use that equation to find that. But we also know that the area of a triangle is just 1/2 base times height. So we're going to use that and the answer that we know for our area, and we're going to take 1,385.8 and set it equal to 1/2 base, which is 60, times our height, which is what we want to find, that length there. When we figure the math out, we get that it is 46.2 inches. Yay!
Okay, so now we're going to do our check, see if our measurements were right. So we'll just measure the distance between our lovely tropical island and our stranded beach, and we get 43.5 inches, which is pretty close to what we got. inches, and we got 46.2 for our own answer. So there is a slight margin of error, but that's because we were just basically eyeballing what the degree is, but I'd say we're